was gonna ask if you can record the lecture since my Zoom keeps on crashing.
Oh, crashing. Got you. Yeah. I'm recording it now.
On the internet.
Yeah, don't worry about it. I'm recording it now.
Okay.
So going forward, they'll be recorded. But this one's here for you, and I'll post these notes up for you guys also. Okay? So let me do this next one. This is also 3.9, and this was number 16 that was asked for. So let me see. My problem is a little bit different than yours, probably, in terms of number. So I'll draw a picture so you can see. It says a plane flying with a constant speed of 240 kilometers per hour passes over a radar station at an altitude of 2 kilometers and climbs at an angle of 30 degrees. At what rate is the distance from the plane to the radar station increasing 1 minute later? Here's my radar station, okay? It tells me that there's a 2 kilometer distance, right? So there's a 2 kilometer distance, and then from there the plane takes off at an angle of 30 degrees. So this little angle here is 30 degrees, right? So it's flying horizontal and then it takes off right when it goes above the station at 30 degrees. Does that make sense?
Yes.
Okay, so then this resulting angle here is 120 degrees. Agreed? Okay. This here is the distance that we're looking for, right? We know that this is 2 kilometers. It's a constant. It doesn't matter. We'll call this my X. We'll call this my Y. Okay? This is not Z, it's a 2. Okay? So that's the height difference that's there. Now, we know that the plane is flying how fast? I told you it was going 240 kilometers per hour, right?
Yes.
We agree? Okay. So now for this problem, it's no longer a right triangle. So since it's no longer a right triangle, we have to use the law of cosines. So the law of cosines tells me I want the y piece, so I'm going to go y squared is equal to x squared plus my c is going to actually be that 2. So I'm just going to make that 2 squared minus 2 times my x times 2 cosine of the resulting angle, which is 120 degrees. Are we all okay with that?
Here.
Okay. So then from here, I'm going to clean up the math real quick before I go into the derivatives. I'm going to get x squared plus 4 minus cosine of 120 is a negative 1/2, correct? So I'm going to get 2x. Agreed?
Yes.
Okay. So then when I take the derivative here, I'm going to go 2y dy dt is equal to 2x dx dt minus 2 dx dt, right? Because I have to do the implicit piece. Does that make sense, Sophia?
Yes.
Okay. We know dx dt, don't we? What we need to find now, and this is where the thing gets a little bit tricky, we need to find out what x is in terms of distance after 1 minute, right? Well, we know it goes 240 kilometers in an hour. So how do we find out how much it does in 1 minute?
Divide by 60.
We have to divide by 60. And when we divide by 60, that gives us an x of 4, correct?
Mm-hmm.
So then what we're going to get is 2 times 4 times 240 minus 2 times 240 is equal to 2y dy dt. Right?
Yes.
But now we need to go and find our y. Well, we can find our y from right here. Right?
Yes.
Okay, so that's going to give us y is equal to the root of 16 plus 4 minus 8. Is that right? 16 plus 8. Oh. Ooh, this should be a plus. My bad. It was a negative 1/2, so this should be a plus. No one
Okay,
told.
dude, I thought I did it wrong.
Yeah. Didn't I say cosine of 120 was a negative 1/2? And then I didn't change the sign, and no one told me. You guys are so mean to me. Waiting to see how long it took me to realize it, huh? Messed up. All right, so then my y is radical 28. So I'm going to get dy dt is 8. I'll do it the easy way. So that's going to be 2400 divided by 2 rad 28. What the heck's that going to be? 1200 divided by root 28. What the heck is that? 1200 divided by... Oops. I got 226.779. Oh, and they want whole numbers, so that should be what? 227 kilometers per. Does that make sense?
Yes, thank you.
Yep. What was it that got you?
It was from 8 plus 2 times 240 over that. I messed that up.
Oh, got it. Okay,
Yeah.
cool.
Thank you.
Any other questions?
Can we do question 13?
13? Yeah. Oh, the infamous ladder problem? God bless ladders, huh? You know, in all my life, I've never had a ladder fall on me or fall while I was on it, which is good. I've seen it happen to people, but it's never happened to me. All right, this is 3.9, number 13. Okay, so my problem says a ladder is 10 feet long, rests against a vertical wall. Okay. Boom, boom, boom. This is 10 feet. We'll call that Z. This will be my Y. This will be my X. What is my dz dt, Carol?
It says 0 because, like...
The ladder's not going to change its length, right? It would be a more complicated problem if the ladder had buckled and started to shrink. We have problems like that, but we're not doing that to you guys. The person's going to get extra jacked if that happens. Okay. Because then gravity comes into it. It becomes a much more complicated problem. Baby steps, right? Okay. So in my problem, it says it's a 10 feet long ladder, rests against a vertical wall. If the bottom of the ladder is falling away from the wall at a rate of dx dt is falling away at a rate of 0.9 feet per second, how fast is the angle between the ladder and the ground? So this angle when x is 8 feet. Okay, so we're trying to find the angle's change. So if the ladder is coming down, what's happening to that angle that is where the base of the ladder is to the ground?
Decreasing.
It should be decreasing, right?
Yeah.
It's getting smaller. We can see, boom, right? Okay, so we should see that our ladder is going to be decreasing. So in order to be able to do this, we have a, what is this? It's a 3, 4, 5. So this has to be 6. Does everyone get what I did there? Where I said, oh, it's a 3, 4, 5?
Yeah.
Is there anyone that doesn't get how
It's a special triangle, right?
Yeah, it's a Pythagorean triple.
Yeah.
So I know that 3 squared plus 4 squared equals 5 squared. If I multiply them by 2, it's still a 3, 4, 5 triangle. So that's what I did there. Okay, so now though, because we're dealing with the angle, we want to set this up in terms of angles. And so cosine of theta is equal to the opposite over the adjacent, correct? The opposite over the adjacent. Ooh, what am I talking about? That's tangent. The opposite over the hypotenuse. Estoy loco. Ow. Ooh. Man, I'm terrible, guys. I'm sorry. Cosine, it's the adjacent over the hypotenuse. Oh. I need a vacation. It's too many computer screens I've been looking at. Sorry, guys. Cosine. Here, just so you guys don't blame me for all these mistakes, okay? Always write this down. I usually get in the habit of doing that. So it's the adjacent over the hypotenuse. The adjacent over the hypotenuse. Ideals. Okay, so now what I need to do is take the derivative of that. So I'm going to get negative sine of theta. D theta dt is equal to 1 over 10. Do you guys agree?
Correct.
Okay, so then sine of theta, d theta dt is equal to a negative 1/10. Ooh, and I forgot my dx dt. Can't forget that variable, I'm sorry. So to make things easy for myself, I'm going to call this a fraction, which is 9/10 feet per second. So I'm going to go sine theta d theta dt is equal to a negative 1 over 10 times 9 over 10. And now, what is sine theta? Sine theta is opposite over hypotenuse. So the opposite is 6 over 10 d theta dt over 9 over 100. Agreed? When we multiply by the reciprocal, and I'll show it because I don't trust myself anymore, what's going to happen here? This will become a 10, this will become a 1, this will become a 2, this will become a 3, and my d theta dt is going to be a negative 3 over 20 feet per second. Does it make sense that it would be a negative number? Let's think about what happened. As the ladder fell, what's happening to the angle where my elbow and my hand are? it's getting smaller, right? So it makes sense that my answer should be a negative. Does that make sense?
Mm-hmm.
Okay. Is there another question?
I had, it was number 12, but just the last two steps, I just didn't know where to go after like a certain point.
Okay. So number 12, the trough problem?
Yeah.
Okay.
Yeah, I managed to get the first three steps, but then I just got completely stuck on the last two.
Okay. I did this one in office hours today too.
Oh, dang.
That's funny. No worries. No worries. It's fine.
Professor, can you promise you'll be in office hours tomorrow?
Yeah.
Can you promise? Because last time I went, you weren't there, and I was like, oh my god.
I show up to it, and then
No, but I was there before you. Like, it wouldn't even let me like go in because there was like no host.
Oh, that's weird. Yeah. So tomorrow, do me a favor. When you're on, shoot me an email to make sure that the link is right, because it should be. Today, actually, I had my son test it for me, and it worked. So I was like, why are people not coming to my office hour? But 2 people showed up to my office hour today. So I was like, okay, good. I sit bored on Tuesdays and Thursdays for an hour and a half. I just sit here like looking at the computer screen like, do my students not like me? So I'll be there tomorrow. Okay. But shoot me an email just so we can confirm that the link is still good. Okay?
Okay, thank you.
Yeah. All right. This is number 12. So you get you have to understand the picture, right? And I think they give you a picture in the problem. Right, Daniel?
Yeah.
So here's the water level. This length is my base. This is my height, right?
Yeah.
This thing here is 3 feet, I believe. And in my problem, it's 3 feet. And then my height in my problem is 1 foot. Is that what you have?
Yeah.
Okay, so the ratio of the triangles is going to be 3/1 should equal base over height. Okay, this will eventually be used for substitution, so the base is 3 times the height. Remember that. Okay?
Okay.
Okay. I'm just trying to go through the problem. It makes me submit answers to be able to go to the next steps on these stupid problems. Hold on. B divided by H. Okay, then the next piece they give you the volume is equal to 1/2, oops, that's crazy, 1/2 base times height times length, correct? All right, so in my problem, my length is 12. So I'm gonna go 1/2 base times height times 12, okay? And then the next piece is I'm going to do a substitution, so I'm going to go 1/2 3h times h times 12. You got this?
Mm-hmm.
So I have 18h squared.
Okay.
I'm trying to get to your part of the question. Okay. And then this piece says, all right, You got the, when you take the derivative, for my problem, I think it was 14 was my volume. And then I'm going to go 18 times 2h dh dt. And so they're asking for this piece, right? They're asking for the constant times the h. Agreed?
Agreed.
And then you got stuck on this part?
Yeah.
Where it asks for h. Now, in my problem, it told me that the depth of the water was 7 inches for this one. But I can't have 7 inches plugged in for h. I have to have it in terms of feet because everything's in terms of feet. You have to keep your units the same. Does that make sense?
Yeah.
So then my h is going to be 7 over 12. Right? If you had 8 inches, you would have gone 2/3 inches or 2/3 feet, right?
Mm-hmm.
And then the next piece, and this is probably where you messed up. My student who asked about it earlier today, it's asking about the decrease, right?
Mm-hmm.
When it goes to the decrease, you can substitute in. All right, 14 is equal to 36 times 7/12. The dH/dt for me was, what was my dH/dt?
And so you got the 7 over 12 because that was just like how deep it was over like the length.
Yeah, that's the depth, right? Because that's the height of the whole problem in terms of water, because we're talking about water. So then from here, you're going to solve this for dH/dt. What's that going to be? 3/21. So 14 divided by 21 is my dH/dt, which reduces to 2/3 is dH/dt, right?
Mm-hmm.
And then the last piece, now that we have dH/dt, let me see what it says. I always have to scroll. It's terrible. That's it. That's the last piece.
And so you got, it was just like right at the top of like where you are, but just 2h, because like you just took the derivative of h squared.
From here to here?
Yeah, from that to that one.
That's power rule, and then chain rule gave me the dH/dt.
Okay.
Chain rule, implicit differentiation, however you want to call it. It's implicit because we don't we're doing it with respect to time, right? Some unknown variable that we cannot solve for. So,
cool.
All right. What else we got?
I had number 15 too.
15?
Yeah.
All right.
The last couple were really messing with me.
Yeah. All right. So you're telling me that I should put the last couple on the test?
The last 3 specifically.
Yeah. I don't agree with on the test, but the last 3. And for me too, because I know we get different numbers, but I had the same angle of elevation and then the same like decrease rate. Like it was the same, and so that really like when I solved it, it just was like really confusing for me.
Are you talking about this 15 problem?
So one more time, say.
Are you talking about number 15?
Yeah. A plane flies horizontally.
All right. Well, here, let me do it. Okay, so it says a plane flies horizontally at an altitude of 3 kilometers. So its height is 3 kilometers, and it's flying horizontally, correct?
Mm-hmm.
Okay. I'm just trying to draw a picture. and passes directly over a tracking telescope. Okay, cool, no worries. When the angle of elevation is pi over 6, this angle is decreasing at a rate of pi over 6. How fast is the plane traveling? Okay, no big deal. So what's happening here is this triangle that I drew would be a bad triangle. Because here the angle is actually this angle, not this angle. Okay?
Mhm.
No big deal, he says. What do you mean, Ray?
Yeah, I wrote it different.
So, because of where the angle is that I need to draw it differently. So my plane is going to be out here. Here is the telescope station, and this is the triangle that I have. This is the x distance that it's flown, and this is the height that it's at. Does that make sense? It totally changes the problem around. Okay? Because now, if you remember your trig, alternate interior angles, that's the angle you would have been looking for, which would be almost counterintuitive to what you're trying to do. Right? So how we draw the picture matters. Right? Because this angle is going to do what as the plane gets further and further away?
It'll get bigger.
Bigger? If I'm out here, isn't this the angle?
Oh yeah, it would get smaller.
It's got to
so
get
it
smaller, right?
contract.
So we should see an angle that is decreasing as we go. And the problem even says the angle is decreasing at some rate.
Mhm.
Right? So if that angle is decreasing, we got to use this picture to see if we can solve it. Okay? Well, we know this is a height is fixed is 3. Right? We know that the rate of change of the plane flying, does it tell us how fast it's going? Oh no. So we don't even need we're not going to need, this is what we're looking for, is how fast the plane is flying. Okay? We know that the angle when they're looking for it is pi over 6, and we know that the rate of change of the angle is a negative pi over 6. Agreed?
So that's the the one you just wrote. So that's negative because it's decreasing.
Correct.
Okay.
If it's getting smaller, I have to put a negative sign. Okay? So now, how do I want to attack this? I need to deal with, and this is important for all of you, I need to deal with x, correct?
Mm-hmm.
And I need to deal with height. Because those are the things I don't know anything about this hypotenuse, right?
Mm-hmm.
So I have to deal with this and this. So what can I use trigonometrically to get
Cotangent?
cotangent will work, right? I could have used tangent also. But if I use tangent, this is important. I could use tangent of theta, but that would have given me opposite over adjacent. I can do it this way. But isn't this a harder derivative than this one? Does that make sense? I will
Sure.
get the same answer, but the one on the right is much easier to differentiate. Agreed? Because over here, I would have gotten secant squared theta d theta dt is equal to a negative 3x squared. Or I could have gone over here and gone negative cosecant squared theta d theta dt is equal to 1/3 dx dt. Now, I have these things so programmed in my dome that I don't need to think about that derivative, but it, the cotangent one to me is a little bit easier. Okay?
Mhm.
All right. So if we use this here, I know the angle specifically that we're using for theta, right? So I'm going to get negative cosecant of pi over 6 squared. My rate of change is a negative pi over 6. Agreed? 1/3. We're looking for the rate of the plane's change. Remember, cosecant is the reciprocal of sine. So what is sine of pi over 6? You don't have those memorized? Isn't it 1/2? Right? It's 1/2. So then I'm going to get a negative 2 squared times a negative pi over 6 is equal to 1/3. Right? So that's going to give me a negative, and a negative is going to give me a positive. I'm going to multiply by 3. So that's going to go away, and I'm going to end up with 2 pi is my dx dt. Now, one of the things that's important is this is kilometers per minute. Per minute. If we wanted to know what that was in terms of per hour, I would just go 2 pi times 60, correct? And what the heck is that? Is that fast? 2 pi, what the heck is pi on this calculator? Well, I'll just estimate. Pretty fast.
So how did you get rid of, because I understand that you get 2 because it was 1/2, and then it's and then you like flip it, so it's 2. But like the negative pi over 6 and the 1/3, that kind of like disappears.
No.
Well, like I'm just like I got all the steps up to that.
Okay,
But then
let me
do
it. Let me do it. Ready?
Okay. Ready.
So negative, and then 2 squared is 4, right?
Mm-hmm.
Okay. Times pi over 6, right? When I get rid of the 1/3 on one side, I need to multiply by 3. Agreed? Sophia, that's a great question. Every problem that I gave you on the homework is fair game. The homework is
Sorry.
intentional.
Sorry, my internet is so unstable. I didn't get to hear your response.
Okay, so I'll say it again. Any homework question I gave is fair game for the exam.
Okay.
Okay? So you really should know how to do all of these problems. Obviously, these angle problems tend to be a little bit more difficult.
Yes.
But I'm spending the time to go over them.
Okay.
But
So-
it is a good question. Ray is really being affirmative in his in support of your
Thank you.
question. Yeah, no problem. Okay, ready, Daniel?
Yeah.
Okay. I'm gonna do it I'm gonna multiply the top, and I'm gonna get, oh, this was negative also. So the negative and negative are gonna go away. What's 4 times 3?
12.
So I have 12 pi over 6.
Oh, okay. And so, because you multiply the other side by 3. Okay, that makes sense when you just got rid of that.
Yeah.
Okay.
Yeah. Okay.
Professor, can you do the side work for the, you said it was like secant is the reciprocal of sin. Can you do the side work
Sure.
for that part?
Sure. So this was side work for the 2 pi. So if I have cosecant of pi over 6, correct? That's the same as 1 over sine of pi over 6, correct? Sine of pi over 6 is equal to 1/2, right? So then that is the same as 1 times 2 over 1, which is 2. When you divide by a fraction, you multiply by the reciprocal.
Thank you so much.
Okay, do you know how I got the 1/2?
Yes, I did. On the circle.
Yeah, here, I don't do it that way. Here's 0, pi over 6, pi over 4, pi over 3, and pi over 2. Okay? Don't ever memorize the circle. It's a joke. Ready? Whole numbers 0, 1, 2, 3, 4. Take the square root. This I literally do in my head every time. So sine at pi over 6 is 1/2 when that's cleaned up. At pi, it's 1. I never memorized that circle. That's sine, okay? Since that's sine, cosine just switches x and y, correct? So now this is 1, rad 3 over 2, rad 2 over 2. This, I should clean up, is 1/2, and this is 0. Have you seen this before?
No, I haven't.
Oh, this looks way better. Yeah.
But it's super easy. Like, you just like.
I never
yes.
thought this real question.
This is real life. This is do it quick, real life, right? I'm not memorizing sine of 45 degrees, because this is also in degrees if you want. And once you know the first quadrant, you have them all. Yes, this is the unit circle. So then look at tangent. What do we know tangent is? Isn't tangent sine over cosine? So what's 0 divided by 1? Oh, 0. What's 1/2 divided by radical 3? It's 1 over radical 3. What's rad 2 over rad 2? Oh, that's 1. What's rad 3 over 2 over 1/2? That's rad 3. What's 1 over 0? That's undefined. There's tangent. Cotangent. Just switch the order. It's undefined here. It's rad 3. It's 1. It's 1 over rad 3. It's 0. Secant and cosecant are just 1 over sine and cosine. Do you see how I just go, oh, 0, 1, 2, 3, square root divided by 2? That way I can fly. Does that make sense?
Mm-hmm.
All right, good. Whole numbers, your first 5 whole numbers. 0, 1, 2, 3, 4. Take the square root of all of them. Divide by 2. You're in the first quadrant. And then to get any other quadrant, just all students take calculus. Right?
Mm-hmm.
Okay. All right, any others?
17.
7? Did you say number 7, Carol?
No, 17.
17.
17.
17. Got it. 3.9, number 17. Okay. So my problem says 2 people start at the same point. One walks east, and the other walks northeast. I need more space. So one walks east, one walks northeast. Okay, the one walking east, I'll call that X, is going at a rate in my problem of 7 miles per hour. Okay? The other person walking northeast, I'll call this Y, dy dt, is going 1 mile per hour. How fast is the distance between the people changing? So how fast is this? I'll call it Z. Changing in 15 minutes. Okay, no big deal. Okay. 15 minutes, we need to think of it in terms of hours because we have our things in terms of hours, correct? Okay, so if someone walks 1 mile an hour, that's pretty slow. Like really slow. How far did they go in 15 minutes? It's a quarter of the rate, right?
Mm-hmm.
That's important. So we know that this is going to be 0.25 miles. And this one's going to be 7/4 miles. Agreed?
Agree.
This angle should be a right angle. Maybe I'm assuming. Let's see. Actually, I am assuming. I should not assume it's a right angle. But I do know that this angle is 45 degrees. Right? Because if one is going east and the other is going northeast, the angle between east and northeast is 45 degrees. Is that clear? Okay, since we can assume that this stupid thing is a right angle, we need to use the law of cosines. So whenever we have triangles, it's either Pythagorean or it's going to be law of cosines. Okay? Since I can't definitely tell you that it is a right angle, I need to use law of cosines. So let's do it. We want to get dz dt, right? That's what we're going after. So I'm going to go, okay, z squared is equal to x squared plus y squared minus 2xy cosine of z. And by the way, that's z. It's the one that corresponds to the side. Right? It's opposite the side. Are we in agreement?
Mhm.
Okay. So let's see what we can do here. Can we clean up stuff? Nah. We can do the cosine of 45, right? So I want to do that. I want to make my life as easy as possible. So cosine of 45 degrees is radical 2 over 2. We just did that, right? Okay, so I'm going to get z squared is equal to x squared plus y squared minus radical 2xy. We all right? Okay. Now let's take the implicit of this thing. So we're going to get 2z dz dt is equal to 2x dx dt plus 2y dy dt minus, oh Lord help us, dx dt y plus x dy dt. Do we agree?
Mhm.
Okay, so then that's a bummer, we can't get rid of the 2. I'm just going to try to clean it up as much as I can so you guys can see all the work. I'm going to get root of 2 y dx dt. This should be a minus root of 2x dy dt. We have some values, don't we? From here, we can find z, right? Because we know what x and y are, right? Remember, x is 7/4, and in fact, I'll write this as a fraction 2 just to make my life easier. That's 1/4. Okay, so y is, here I'll write it down, y is 1/4, x was 7/4. Okay? What the heck is z gonna be? Dang it, I guess I'll have to do it. Z is going to be, and I'll just write it right here and then, I won't erase it. 1/4 squared plus 7/4 squared minus root of 2 times 1/4 times 7/4. What the heck? 50/16 minus root of 2, 7/2/16, which will be 1/4. 50 minus 7/2. So I wrote down all the steps for that so you guys can see it. Okay? Now, that's the side work. Back to the problem. 2 times 1/4 root of 50 minus 7/2 dz dt, which is what we're looking for, times 2 7/4. dx dt was 7, correct? dy dt was 1. Fourth. Seven fourths minus root of 2 x was 7/4. Ooh, my bad. This should just be 7. And this should be 1. We all right? All right, so then dz dt, let's see, 49 over 2, I'll keep this here, 1/2 root of 50 minus 7 root 2 plus 1/2 minus 7 root 2 over 4 minus 7 root 2 over 4 oh, this is cute. It's going to end up being something pretty. Well, relatively pretty. Doesn't that become 50? 50 divided by 2 is 25. Minus 14 over 4 is going to be 7 over 2 root 2. That's cool. And then I'm going to get dz dt is equal to 50 minus 7 root 2 over root 50 minus 7 root 2. Oh, but that even cleans up. 2, 50 minus 7 root 2. Do you guys agree with that? Or did I go too fast? Algebra's cool, huh? You guys are like, oh man, algebra. I thought calculus was just like something different. I didn't know it was going to be algebra. Does everyone agree how I got from the second to last step to the last step? Or do I need to show the step in between?
Show the step, please.
Sure. So I have 50 minus 7 root 2 to the first power over 50 minus 7 root 2 to the half power. So that becomes 50 minus 7 root 2 to the 1 minus 1/2, which becomes 50 to the 1/2 power. Right? Because they have the same base. 50 minus 7 root 2. Agreed?
Mm-hmm.
Who would have thought calculus was so much fun, right, guys? Yay.
Super.
Don't worry, you guys will kick butt on the test. It's gonna be it'll be on the easier side. I won't try to surprise you with anything, really.
Could you scroll up just a little bit? I didn't get like that. Oh God. Okay. How did you get that 1/4? When you divided by the 16 and like the end of like the radical.
Here?
Yeah.
It's in the denominator, right? What is the square root of 16?
Oh, 4. Oh, so you factored it out?
Yeah, because it's in the denominator. So
oh, okay.
Yeah. Yeah, that's why. Does that make sense?
Yeah.
Cool. Any others? Do you guys still love me?
Oh, if you could do 16.
16? The one that I just did, you mean?
This was 17, right?
Yeah, I did 16 before this one.
No, that was 15, I think.
That's 17.
Unless,
That's 15. Didn't I do 16?
if it might have been 16 earlier.
Right there. Yeah, it was one of the ones I did
Oh.
earlier.
Dang. Okay. Sorry, that was on me then.
Yeah,
Never mind.
it was recorded. That one was recorded. The first one was not, but that one was recorded. So you can just watch
Okay.
the video and see that one, 16.
Okay.
Are there any other questions from potentially different sections or anything like that? It does. The thing is, and this is the honest to God truth, Jose. These problems they all follow the same pattern. It's just how do you decipher what technique to use? So like, look, going back to, what was that problem? Oh, this one, right? I couldn't decide if this was a right angle or not. And since I couldn't decide if it was a right angle or not, to be safe, I had to use the law of cosines, which drove us crazy, right? This problem over here, with the ladder, this was a right angle. Oh, no. Well, it was a right angle, but I didn't use the right angle because it didn't address what I was going for in the problem in terms of angles. I would have gotten all three sides, but I wouldn't have been able to get the rate of change of the angle. Does that make sense? So just because the ladder's falling, if it asks you for the angle, you can't use Pythagorean theorem because it won't get you the angle that you want. So then you have to do reference to the angles. It's all about how you attack these problems. Does that make sense? To what extent? Do they fit on your sheet of paper that I'm gonna let you use on the exam? To that extent. I would write those down. They're gonna be used. You should have them on your piece of paper. Do you want me to write them down so you know them?
Yes.
Okay. So here we go. Law of sines you probably won't use, to be honest, because it's a ratio, right? Like a law of sines, if you remember, it was sine of A over A is equal to sine of B over B is equal to sine of C over C, right? We're not going to really do that one, but the law of cosines will come into play. So law of cosines says if I have A squared Yeah, I can do that one, no problem. That's the law of cosines. Pythagorean is x squared plus y squared is equal to z squared, right? These are the classics that you're going to end up using for these problems. When you're going after angles, you're going to have to know SOHCAHTOA, right? Like these are things that you should have and write down on your paper for these types of problems. It will be beneficial to you. Now, you know, I've got 5 million years of mathematical experience, and so like they live up here. But like You're not there yet. You'll get there one day, but you're not there yet.
Would you say we have more than 2 questions like this in the exam of like the word problem?
Oh, that's funny.
If you keep asking, he's gonna make it more than half the test.
Well,
Honestly, because like it takes me like a long time to solve one, so I'm just like I have to practice more.
So what's pretty funny is today we were talking about that. One person was asking me about the exams and whatnot, and asked me like, you know, how do you decide how long exams are? And I go, well, I take the exam once I've written it, and I multiply the time that it took me by 6 for you.
How about by 10?
So that's just, you know, because there's, for one, yeah, I know all the steps, so you probably have to think about the steps where I don't, and so I typically multiply by 6. So if it takes me 20 minutes, it should take you guys 6 times that. Right? So if a test takes me 20 minutes, it should take you guys about 2 hours.
You really did like 20 questions in like 20 minutes? Like
Of these
Like-
these problems?
yeah. Like you just like blew through them?
Yeah.
Wow.
Really impressive.
That's a very short amount of time.
Well, but you got to think about it. It's like if I gave you guys, okay, so if you spent as much time as I have in math, right? You kind of see the techniques of these problems. So take if you have a sibling and they're doing multiplication problems,
Huh?
right? You're gonna fly through the multiplication problems that they do, right? My daughter, when she was like in 2nd grade or 3rd grade, they'd have these multiplication things with 50 multiplication questions, and she'd have to answer them in a minute, how fast she could do it, right?
Mhm.
Well, her and I would do it, and she'd be like, how many times can you do it, Dad? And I would do it like 3 times her amount. There's a asymptote, right? As fast as you can breathe and talk. But yeah, it's the same thing. You're going to be faster at multiplying than your young sibling. This is the same thing for me. Do you guys want to know how long I've been teaching calculus? I've been teaching calculus every year since 2007. Teaching it. That's not even like me knowing the calculus, me teaching it.
Long time.
Yeah. Like my calculus students when I taught high school, they were so smart. My success rate in my AP calculus class was over 90%. It was like 92 point something percent. Over the whole time I taught it for 10 years at the high school level. So, actually, dude, I've been teaching it longer than that, dude. 2007. It's been a long time. So you should take that 20 problems and multiply by 13. Look, if it takes me 20 minutes and it takes you guys 2 hours, you still have a 30-minute buffer. So you'll have plenty of time. Okay, someone asked for a different question, so let me go do that.
Wait, I have a question real quick. What's this SOHCAHTOA again? What it stands for? I forgot what the S and O sign.
Do you also teach Calc 2 a lot?
I'm teaching Calc 2 right now. Yeah, I'll be teaching it next semester too. And do you need the rest of these, or you got it now?
No, we're good. Thank you.
Okay. The last one's adjacent, right?
These are just like course questions, not like questions. But the first thing, just like on Canvas, the 3.9 like the video is there, but just the notes aren't, like the blank ones are. So I was just wondering if you could, like, whenever you have time,
Put the completed ones?
yeah,
What?
for the related rates.
You didn't go and fill them in? You want me to give
Well,
you
I
a filled
did,
out one
but,
so you can
but
just
some
set
of
my
like
phone?
your examples and stuff, like, because you have like the calc brain, whereas this is like, like most of our first time with calc, and so it's easier to like look at examples like that when I'm doing the homework.
Got you. Yeah, no worries. I can put that up today.
Okay, cool.
Someone
And then just
asked-
another thing is I got a notification on my Canvas app. It said the grade weight was changed, but I couldn't like see anything for that because I didn't like input
Oh,
stuff.
so if you go
what
to,
does that like mean?
So if you go to the grades, I put your grades on Canvas.
Yeah.
So that's it. I made it so that I would put every assignment that's on WebAssign on Canvas. That's all it did.
Okay.
So
The percentages are still the same, like from the syllabus?
yes, it's exactly the syllabus. It's just I broke it down so that it's exactly like it would be. Instead of just giving you one WebAssign grade, I just put everything on Canvas so you guys can see everything.
Okay.
Does that make sense?
Yeah,
So-
I just wasn't sure if that meant something like
Yeah.
suspicious or anything.
So I'll tell you this, just for all of you, just being frank, there's a couple things that's going to get you in my class. Number one, discussion is going to hurt people's grades. It's enough points that it's going to ding people. So you guys make sure you're participating with the discussions. Number two, homework is going to hurt people. Homework being 10% of your grade, people don't realize. There was people last semester who got passing grades on exams and ended up not passing the class because of homework. Because
I have a question. Oh, sorry.
yeah, sure. I'll get to your question in just a second. Because they took for granted the discussions and they took for granted the homework. All right. What was the question?
The week 7 discussion.
Mhm.
When did you put that up? Because I didn't see it on Saturday, I think. But it says it was due Sunday.
It should be due.
I don't know
this-
if maybe that's supposed to be
I
the
may have put the
4th
wrong
of
date on there,
October.
so I can fix that. It's supposed to be due this Saturday coming up. It's supposed to be due October 3rd. Did it
It
make
says
it?
right
Oh,
on
okay.
it.
Okay, so I'll fix that. That's funny. It was supposed to be due. I'll fix that. You'll have till Saturday.
The week 7 discussion?
Yeah,
Oh, okay, yeah.
We're
No,
in-
that says it was yesterday.
yeah.
Um,
we're in week 7 right now.
Oh, okay, yeah.
So
For
yeah, I'll
week
fix that.
5, like, I totally forgot about the discussions, and now that you said that it matters, I'm like, oh, geez.
Yeah. So just so you get an idea, hold on. So all of you guys get this. It's discussions are 4% of your grade. It's not something crazy, but like when you miss discussions, what it ends up doing is if you end up with like an 89% or a 79%, I'm going to look at discussions. You know what I mean? Because those are things that you can easily just be like, hey, I had a question. It's not really a real question, but I have a question, so I get my points for discussion. I mean, come on, we're playing the game, right? Let's be honest about the game.
Mhm.
So for those points, post your questions and interact with each other. Because really my whole point of the discussions is for you guys to build relationship with each other so that instead of me always having to answer questions, you guys can go to each other. Because who does that help? It helps you guys. Does that make sense?
Mhm.
So do we get extra credit if we have a group chat? Because we're very involved there.
There is a group chat?
Yes,
How
multiple.
how am I supposed to know about the group chat?
I'll send you a picture. No.
Why don't you do the group chat in the discussion? And look, it's cool. You look, let me just be I want to be frank with you. If you guys have critiques about me as a professor, by all means put them on there. Talk to each other. Then bring up the discussion to me so that I can improve. I'm not opposed to being critiqued, guys. In fact, I think it's good for me as a professor to improve. So it doesn't have to be. Now, I do understand that texting and having those is beneficial because you get this immediate thing. You don't have to go to Canvas, right? So I do understand that too. But also allow other people in the class that aren't part of your discussion chat thing to be able to benefit from it too. Does that make sense?
Completely, yeah.
Yeah.
They had the chats. No.
You guys did share each other's phone numbers and whatnot on the chat, and I don't share those videos so no one else knows your phone numbers. So you guys are funny. Okay, there was a question I want to get to. Someone asked, let me see. Homework 4, number 6. Okay.
No, it's in homework 6 and question number 4.
Oh, question 4 and homework 6. Yeah, I can't read. Thank you. I don't know how I solve the word problems. Questions. All right, number 4. All right. Here we go. Ready? So this is section 3.1. This is number 6 from assignment 6. Just so everyone
It's supposed to be number 4, question number 4.
Oh, that's funny. I'm looking at question number 4, but I wrote 6. I told you I can't read. I have many weaknesses, Ray. Many. In fact, the only strength I have is mathematics. Honestly. All right, here we go. Now, giveaway. Giveaway on this problem is this. See how it's saying z of y? Since it's talking about z of y, we're taking the derivative with respect to y. Okay? So my z prime of y is going to be negative 15 y to the 15th a. Not negative 15, 14. Okay? Plus b e to the y. That probably didn't help you at all, huh? I just did it in my head, sorry. Okay, let me do it so you can see. So if I have z is equal to y, ay to the negative 14 plus b e to the y, okay? Power rule tells me to go the negative 14 is going to come out front, correct? Y to the negative 14 minus 1, agree? Then b, what is the derivative of e? Isn't it itself? So I get e to the y. So when I clean this up, I'm going to get negative 14 y to the negative 15 plus b e to the y, which is a negative 14 y to the over y to the 15 plus b e to the y, which is, ooh, I forgot the a. Does that help? Okay, cool. Yeah, sorry. So, like, these are the types of problems that, like, 6 times, right? That's why 6 times. All right. Any other questions? I do think it's cool that you guys are doing chats, by the way, with each other. That's cool. It's really cool. Any other questions? Or you guys just need to go study?
Study.
All right. So the test will, let's see. Let's talk about the test real quick just so you guys can get an idea. So we had 3-1, 3-2, 3-3, 3-4, 3-5, 3-6, and 3-9 were the sections that we went through, correct?
Mm.
So that's 1, 2, 3, 4, 5, 6, 7 areas. What'll probably end up happening is your test will be 10 questions long, where these two will just be embedded in the other sections. Does that make sense?
Mm.
So what'll probably end up happening is your test will look like this. Maybe 1 question from here, 2 questions from here, 2 questions from here, 2 questions from here, and then 3 from here. So you can see where the test is coming from.
Mm.
Yeah, I gotta write it. Do you guys think I'd use the same exam every year? I give them away. I let people have them. Keep them. Use this. Oh, I change my stuff every year. No, I change them around. Just so you get an idea, like no joke. No, so I don't use WebAssign when I'm not in the classroom. Is totally different. I make those tests up in my head. Like I make them from scratch. In this new brave world we live in, I'm just using WebAssigns, but I'm thinking about, all right, how can I test you so that I can incorporate multiple steps in one problem, right? So like, I know that the problems that I give you in chapter or in 3.9 are going to incorporate so much of what's in chapter 3, right? So it's going to reinforce testing a lot of the stuff that's in 3.1, 3.2, even 3.3. That's why there's only 1 question from 3.3. That's like the gimme, right?
Mm-hmm.
I mean, I might change it. I maybe will do like 2 and 2, but there's going to be 10 questions on your exam. So when you think about 10 questions for an exam, and that's going to be standard, I think, for all my exams. 10 questions, you have, what, 150 minutes? Oh, yeah, yes. You get 2 tries on everything. Correct, yes, right. Yeah, I think that's me trying to be cool to you guys, you know. 150 minutes, that means that you're getting 15 minutes per question. That's a lot of time per question, right? I mean, that's a lot of time. Oh no, for sure. So like, yeah. Now that's where and the reason I do that, Ray, is because if we were in class, I would walk around, and if I saw a mistake that a student made that was something that was kind of minor, I'd be like, hey, you want to be careful about that. Like I'd point at it like, hey, be careful with that. Since I cannot do that during this COVID new lifestyle, I'm giving you 2 tries. Because my professors, when I was a student, they would do that, right? They would come by and be like, hey, are you sure? Like, oh man, dang it. You know, and sometimes some people hate that, which I get. So maybe in the COVID era, having 2 tries is beneficial because it just tells you. And then you don't have to feel emotions from me, right? Like you're like, oh, this guy's picking on me. I'm not trying to pick, I'm trying to help. Some people get mad at me though for that, so. All right, if you guys don't have any questions, I am trying, look, if I'm really, really frank with you guys, the grades don't matter to me at all. An A, a B, a C, that stuff doesn't matter to me. I want you guys to know the material. Oftentimes, students get caught up caring about grades, and I can tell you, I know students who have B's and C's who actually know more than students that have A's in terms of their understanding. Just they could have had a bad exam, right? Could have been sick. All kinds of stuff happens. So your knowledge isn't totally dictated by your grades. And don't ever misconceive that, right? I always tell my kids the same thing, my own children. Just because you have an A doesn't mean you know it all. Because I can give you a problem right now that eats you up, and then my son gets mad at me, or my daughter gets mad at me. I'm like, look, you're an A student, right? You know this stuff. Here's this problem. Tell me how to do it. And they're like, ah. There's always something to learn and grow on. So my biggest thing for you guys is always continue to learn, right? Even this calculus stuff, I've been doing it all this time. I'm still learning things, new tricks, new techniques, how to explain it. I think it's so neat. All right, I'm gonna stop recording. Hopefully no one has any more questions, but